Getting closure to hooks. I'm going to assume everyone kind of sort of knows what hooks are. They're announced in October of last year and released only last month, so actually fairly recent. With hooks, they're supposed to solve some pain points around class components and moving them to function components. A lot of people feel that we exchange the issues that we have with class components with new problems to do with closures and hooks. So I thought it might be a good idea to spend this talk talking about a little bit about closures, refreshing people if you've been a bit stale. That's a joke. So MDN says a closure is a combination of a function and the lexical environment within which that function was declared. That's super obvious, right? And if you look around, it's very hard to find an accessible explanation of what closures are. And really, the best one for the purpose of this talk comes from W3 Schools, which I thought I would never say. Closure makes it possible for a function to have private variables. Thank you, W3 Schools, close tab. So we'll just do a little quick example to refresh everyone's mind. If you're familiar with JavaScript, you will have run into something like this, where we have a counter variable on the global scope. We have a function that modifies that global variable, and every time we call that function, it modifies that global variable. This is all well and good as long as you have control of every part of your code. But the moment something is modifying that global variable in the middle, it starts to become unpredictable what the output of your function calls are, right? So it's not scoped. The variable is just global. Anyone can touch it. So we can just move that variable inside of the function, inside the scope of this add function that I'm writing, and now it can't be touched by anyone else because it's just contained within the function. But unfortunately, you also can't edit it. It's just going to run and return the same result every single time. So the way to solve this is to wrap that function in another function. Your dog, I heard you like functions. And that internal, and when you return that function, you close over that function that's that counter variable that's contained in that function. And so now every time I call this add function, it increments and it has state within that function. But also it can't be touched by anyone else, and that's the kind of encapsulation that you want. And that's what closure gives you. So to really sort of tighten up the code, you can also move that bracket kind of in there, and it's called an iffy. This is also called the module pattern, and all these is a nice primer for what we're about to do, which is talk about React hooks. Now, a lot of times, like, people are presented with React hooks as though it's like a big shift in how idiomatic React goes from class components to function components. And that's largely true, but they're not just new ways to do the same old things. I actually have a talk called React's New Defaults, where I talk a little bit about what the defaults are doing and changing in React, including with concurrent React. I don't have time to cover that, but ask me about it later. And really, there's a lot of complaints when it comes to thinking and talking about hooks. They're too magic. They run into problems with stale closures. People make fun of JavaScript developers because we have a problem with this keyword. And they rely on static call order. And so I think it's best to have a good mental model because it's really not that magic. And the way to do it is to write hooks from scratch. Now, this seems like they've worked on this for months and months. This seems like a monumental task, but it's actually not. And that's why I can present it to you in 10 minutes. So previously, if you remember the counter function that we did, this is exactly what we ended with, and this kind of looks like set state, use state, set state. So if we move that code around and store the internal value as that state, and then we return two functions, a getter function and a set state function, and we'll call those functions state and set state, and now we can use that inside of our code. So for example, I can say use state 0 here, and that the value of that is 0. I can set foo there. I can set that state to 1, and when I call the getter again, it's called 1. So the state is contained within the closure of that function. But this is not exactly React's API. We don't have a getter function. We just have the variable, right? We just can somehow use it like it's just current every single time. So how do we achieve that? The way to do it is to wrap it inside of the module, similar to what we just did earlier. And we'll just call this React. It's not React, but you know. And we'll just say we're returning an object. The object has a method called useState. It has exactly what we just went through just now. But now we don't have to put in a getter function. We can just return the underlying value because every time we call it, it's going to be assigned from the stored underscore val function that we have in React's scope. So then the other thing that we need to do is we need to turn over inversion of control of rendering from the components level to React. We need to hand it over. So this is the analogy of React.render. And so with these two functions, we can do a lot with that. And we can actually write a component already. Let's say this is a counter component, and instead of rendering to the DOM, I'm just logging stuff out to the console. And I also return a handler. So here I return a handler called click, and every time I run that handler, it increments the state by 1. And so now here I can say app equals React.render counter, and that renders 0 because that's the initial state. And then I can click it, and then when I re-render, it increments by 1. And that's kind of React's API, yeah, if you squint. And so that's use state, but there are more hooks. And the other one, my favorite hook, is use effect because that gives you so much power. And so you can implement use effect in much the same way. So use effect takes a callback in the dependency array. If the use effect has no dependencies, or if it has change dependencies, we're going to call the callback, and that's about it. And that's the entirety of use effect. Obviously, it's not because you have to do the unsubscribe. And so now we can write components that have use state, React.use state over here, as well as use effect. And I don't have time to show you this, but you can write a full test with that effect. Actually, yeah, well, I already did. So here you can render the counter. You can see that effect is run on the first try. In real React, effect is actually run after render. You can click and change the state, and now when you re-render again, you're rerunning the effect. If you run in no op and do not change the state, so count is still 1 here, no effect is run because the dependency is depending on the count. And if you click it again, the effect is rerun. So that's a very solid way to understand how these hooks interact with each other. And so now the problem with this model is that we've implemented everything as singletons. And Rudy Yardley actually wrote this awesome Medium post stating that hooks are not magic and just arrays. And you can model hooks in components as just arrays of effects, whether they modify your internal state or some external state. So the old structure is this is what we set up in the original slides earlier. We had one variable for internal value and one variable for the dependencies that the use effect was on. So what if we just generalize that to just an array? And then what if we just had a pointer to the current array that we're working on? And so now we can take that and just rewrite bits of each of the code that you've already seen. I'm not going to walk you through that, I don't have time. But that's the entire line. This is 28 lines of code for the entire implementation of the mini React hooks clone. I just want you to focus on these particular lines. And that's just an array of hooks. Every time we render, we set it to 0. Every time we run a hook, we increment that counter by 1. And we access the hook that lives at that counter. And so what that does for us is that we are now able to write components with multiple hooks. And that's React. So here's a component with 2 use states and 2 use effects. And that's pretty close to what we have with React. And so that's a lot that we covered. So who wants to write the code for custom hooks? Do we have another 10 minutes? No? It's fine because we already did it. We get custom hooks for free. And that comes out of the design of hooks, which is just function composition. So here I have a custom hook called useSplitURL. I just do some modification on a string. But I can use that custom hook I just wrote in my sort of demo little hooks model, and it just works. And that's a really good way to understand like what the magic is and where the magic stops in React when it comes to hooks. And so you also can use this model to study the rules of hooks. So what's the first rule of hooks? You have to call things unconditionally or consistent call order. And if you take this model of React where we're iterating through a hook array every single time we render, and if you take this kind of component where you have an if statement around a hook, you can start to see that there's some uncertainty around what the index of the hook is when you call hooks that are after that conditional hook, right? So that's a really good way to think about this. I'm not saying that this is exactly what they do, but it's a good mental model. The second one as well is kind of similar. If you can only call hooks inside of components and other hooks. So if you try to call it outside, what is the index of this hook? 0, 1, I don't know. And then what? And if you have that externally, what is the index of this hook if it's called within the component and it renders a few times? So like the call order starts to get out of sync, and you start to get errors. And so that's the mental model that I think I want to establish today. There are other exercises that I really want people to take home because it's not that hard. For example, you can write useRef in 1 line, just as a function of useState. You can write useReducer in 3 lines, again as a function of useState, or the other way around, useState as a function of useReducer. And so. I helped to moderate the r/React.js subreddit. There's 100,000 of us React developers discussing this stuff. We ran a hooks contest, and you can see all the creativity that comes out of it. So my recommendation is also to have that you should also check out use hooks. These are like community contributed hooks that help you think through edge cases that you may not think about when implementing these things, and you really learn how to write your own custom hooks. My custom hook though is a little more ambitious. So I wrote one called use create class. And that just like you take if you're old school React, you have the create class API where you had an object. So I took that, including mixins, and I just cloned it all over to hooks, and I went through every single lifecycle method and implemented them with hooks. And that is an exercise. That is an awesome exercise to really understand the mapping, right, of component lifecycles to hooks. And also, I just really like the idea of using mixins inside classes inside hooks. Right? Yeah, all right. This is the only crowd that works. And so the last question I want to leave you with is, if I can write a hooks API clone in 28 lines of code, then what does React do? I have an answer. I think you have yours. Let's talk about it. My name is Sean. You can find links to this talk, Twix.io, as well as the Netlify blog. Thank you.